which is the strongest base of all these options? Alright, so what we're going to want to look at is which of these guys is most stable, most likely, right? For acidity, basicity, right, we're concerned with this equation, H plus, A minus. So the more stable this guy is, the less likely it's about to go that way. So the more stable the base is, the less likely it's going to pick up a proton. The stronger the acid it will be, the weaker the conjugate base. So think over that, right? So we should know amines have, well, protonated amines have a pKa of approximately 15. With the benzene ring, if this is benzene ring, right, it makes pKa approximately 10. Okay, so just some side notes. So what this is about is, okay, which one of these is the strongest base? So which one of these is least stable, most likely to pick up a proton? Okay, so NO2 is a deactivating substituent on benzene rings. So it pulls electron density away from these guys. And what's that? It pulls it away from the end, so that'll make this more positive. The more deactivating substituents there are, which will make it less likely to pick up a positive proton. So it'll be a weaker base, right? We can show this through resonance. So, for example, this would be, we can draw like this, O minus, right? That's NO2, right? So we could move some positive charge here, like so. We go here and here, right? Okay, so what we just did was O minus, went here, here, N, H2, positive charge. Right, so now this guy with the positive charge, it's not going to pick up a proton. That's not going to happen, right? And so the more of these NO2 groups, the weaker this base will get. So this guy's a weaker base than this guy, right? But in general, this is a weaker base than this guy because it doesn't have the same resonance, right? So this guy we could do in resonance here, but we end up with a minus charge in the ring if we do that, right? We'd have to go like this, and we could get a positive charge here, and we could move this guy around the ring, right? But we can't delocalize that minus charge as well as we can with this, right? With just an ordinary benzene ring. So this guy, this is an sp3 carbon. So there is no delocalization of this base with the electrons. So this will be the strongest base. You can also think strongest base will be the weakest conjugate acid, right? And I said the conjugate acid of this is RNH3+, which is approximately 15 pKa. The conjugate acid of all of these guys, if I picked up a proton, would be benzene as our R group, NH3+, which drops this pKa by 5, makes the pKa about 10. Right? So these guys are stronger acids, meaning its conjugate base is weaker than this guy, right? So this is strongest base.